I grew up in Southern California, so the geology is exposed to you. Plus I was at an age where sports activities were the kind of things that took you outdoors a lot, and I enjoyed that. Between surfing and motorcycle riding in the desert and stuff, you were exposed to a lot of the geology of Southern California. So that combined with the fact that my father was truly a rocket scientist. He was one of the early aerospace people in San Diego in the 60s. It was a combination of a scientific background and exposure to the natural world that I liked very much. I was always attracted to physics and sort of basic chemistry and how things work at an atomic level. But I also like going out into the world and seeing the natural world. So to me, the combination of chemistry as applied to geology seemed like the right thing to do. I work a lot in combination with a lot of different disciplines, so seismology to geophysics and computational geodynamics, and then I'm the geochemist of the group. But we've done a lot of studies looking at how continents form. And this comes from a combination of myself and my colleagues like Steve Shire are responsible for developing a technique that lets us date rocks that come out of the mantle. One of the first projects that we did this way was in Southern Africa, where it combined a large seismic project to image the mantle underneath South Africa, and then also we were working on pieces of the African mantle that were brought up in kimberlites, where we could actually do the chemistry and the chronology of them. So basically we put together a four-dimensional map of Southern Africa, where the crustal geology was well known by people before, and we've added the third dimension going down to about 200 kilometers in the mantle. And the key finding, I think, is the fact that a continent is not just its crust, but it's this big, thick section of mantle underneath it, and it's probably the mantle that allows continents to survive over Earth history. Geology is kind of a test of the basic sciences, because nature is controlled by physical laws, but it's one of the most complicated expressions of them around. So we're working in areas that range from how elements are made in stars. So this is an area I'm working in now, is nucleosynthesis, and using it basically as a way to trace the chemical composition of our solar nebula, and then how that chemical composition got translated into the composition of planets. So you're going from basic astrophysics and nuclear physics into really geology. So the geologic record is the book of everything that happened from the time our elements were made in the stars until it's the way that it is now. So I like covering that whole aspect of the field. So you work in this field and you keep your head down and you do what you're doing, and science by nature is one where people question what you do. I mean, that's the scientific method, is you look at other people's results and you try to decide whether they're right or wrong, and by nature you're critical about this. So most of the time you're in arguments with your colleagues all the time, and you never really appreciate the fact that sometimes people recognize that something you did is a good achievement. So winning an award like this is just fantastic. As you're growing up in the field, the first meetings you go to are the Geological Society of America. All the famous people, all your heroes at that time are the members of the society and the leaders. And then to think that after 30 years in the field you're moving into that category, it's something I never expected, but I'm very happy to be here and very honored to be a part of it.